Good day. So today we're going to be doing the increase in triplet subsequence on LeetCode. So given an integer array nums, return true if there exists a triple of indices I, j, k, such that I less than j less than k, and nums I less than nums j less than nums k. So if there are no such indices, return false. So the first thing that they want us to do here is, well, actually, let's just start with the example. So they give us 1, 2, 3, 4, 5. So basically within the, well, in this given array, there's multiple cases of it, but we can see that we can see there's multiple cases of there being three values within the array that are in ascending order, basically. And then in the second example, we can see that there's no cases of that. Since it's in descending order, there's no way that we could have a value at a higher index in the array that is greater than a value at a lower index in the array. Well, there's no left value in the array that's going to be higher than a right than any value to its right. So if we look at the constraints here, so this second constraint here basically is gonna be a little bit of a thing. So we're gonna have to set our numbers to be very large, so that whenever we make a comparison, we will have to check to make sure that we're not like that the value will be smaller than this, so that we can kind of start off everything. Otherwise, we kind of risk just having values that just don't compare properly. So if you just start getting into the code here, the input is an integer array. Yeah, the input is nums, which is an integer array, and our return is a bool. So we don't actually have to keep track of the indices, we just need to return if it's true or false. And there are three numbers in the given array. So basically what they're asking is that they want us to see if there are three numbers in the given array which ascend in value given the order of the array. So if there's only, so the cases that I came up with are if there's only one value in the array, there are three values which ascend in value, and then there are no values which ascend in value. So let's just get into pseudocode there. So I kind of mixed up the labeling a little bit for this. So basically what we want to do is we want to have this actually being I and j. So basically what we're going to do is we're going to use I and j to keep track of the smallest and the second smallest of the two values, and then we're going to iterate with k so that we can get the largest value. So k is going to store this potential largest value. So the first thing we're going to do is check and see if k is less than or equal to I. So if k is less than or equal to I, we're going to use this as our smallest value. So then we set I equal to k. Else if j is less than or equal to k, in this case will be if k is less than or equal to j, then we know that j is that k is less than j, and we don't really want that, so we set j to be k. And then if we go through all three of these, so if k is not less than I, k is not less than j, then we know that we found three consecutive numbers that are in ascending order, because we know that I will always be bigger than j. And then if k is bigger than I and bigger than j, then we can safely just say that it's in ascending order. So let's just get into the actual code. So we're just gonna initialize this to the 2 to the power of 32, I believe this is, so that we have values bigger than this for a comparison. This is just I believe this is just standard for making sure that we can make those comparisons without worrying about if the value is too small or too big, since we do have to worry about negative values in this case as well. So just running through it here very quickly, we do for k in nums, if k is less than I, then we just initialize I. Well, not initialize, we set I to k. Else if k is less than or equal to j, then we set j to k. So by doing this, we basically just ensure that I is the smallest, j is the second smallest, and then if both of these conditions are not true, then we can just say that I is in fact smaller than j, and j is smaller than this current value that we're looking at, which is k. So we just return true. if we go through this entire thing without reaching this return statement here, then we can safely say that there is no three consecutive values where I less than j less than where well not yeah I less than j less than k. So yeah, and if we just submit this, yeah. So there we go. All right. Well, thank you.